Okay, hello. I'm just going to work assignment 7 here, or this particular problem. Um, just, if you had any questions for how I did things and that sort of thing, because, we don't get to do this in class. Okay, so here's the Venturi. You've already read this, so you kind of already know what's going on. So I'm not going to read the problem to you, but, you have time to read it. Okay, so the first thing this thing asks for in part A, it says the speed of the water in both cross-sectional areas. Okay, so we need the speed here, and we need the speed here. Okay. Also notice, a lot of times in a problem, they won't necessarily give us where they want these points, but remember, we're going to want our points to be at the center lines where the manometer comes in, okay, because that's where we have the most information. Okay, so to get those velocities, V1 is Q over A1. Okay, so if we plug those numbers in, that's 5 times 10 to the minus, let's, we're never going to fit this on here, or it's just going to be crazy. Let's zoom in a little bit so that this doesn't look so huge. All right, so it didn't take up so much space. Okay, so Q equals V1A1. Okay, so we rearrange that to V1 equals Q over A1. Okay, so if I plug in numbers, 5 times 10 to the negative 3, we're in CMS, cubic meters per second, and we'll divide that by the area at 1, and the area at 1 is 2.5 times 10 to the negative 3 square meters. Okay, so V1 equals 2 meters per second. Okay, and using the exact same logic for V2, but using, instead of this, we'll use the other area there, which is 4 times 10 to the minus 4 square meters. We'll get V2 equals 12.5 meters per second. Okay. All right, so that was part A. You guys did pretty well on that one, aside from a few, typos or whatever. Okay, so then the pressure difference. A lot of you guys got the wrong sign on this pressure difference. I don't really understand why that keeps happening, but let's go ahead and let's get at it. So one of the logical ways to get, so there's really two ways to get a pressure difference between 1 and 2, okay? And one is we can do Bernoulli along the streamline. Okay, so we can do Bernoulli here. And the other possibility is we can do hydrostatics through the manometer. Problem with the manometer is this H is unknown, so we can't really do that. So we'll do Bernoulli from 1 to 2. Oh wait, let's make this A. So here's B. Okay, we're going to do Bernoulli. And so that's, P1 over gamma plus Z1 plus V1 squared on 2G equals P2 on gamma plus Z2 plus V2 squared on 2G. Okay, noting that first thing we're going to do is we're going to make this our datum. Okay, because that way our z's go away because they're on the datum. Okay, we have different velocities in both locations as we noted right here. Okay, so we can plug those in, and we've got P1 and P2. Okay, so we're going to solve for the difference. Now it doesn't matter if you get P1 minus P2 or P2 minus P1, but you have to label which one you got, right? So one way we can rearrange this is we can rearrange this as P1 minus P2 equals gamma times, let's see here, V2 squared minus V1 squared on 2G. Okay, so that's just algebraic rearrangement. So we can call this, if we want, we can call this delta P. You could have also ended up with delta P equals P2 minus P1. That's the way I ended up with it on the key, which is already posted to Moodle. So then gamma here is, what system are we? Meters per second. So 9810 newtons per meter cubed. Okay, times V2 squared, so that's 12.5. So you can see this is going to end up being a positive number because V2 is larger than V1. okay, minus 2 meters per second squared, all over 2 times 9.81 meters per second squared. Okay, checking units, this is going to give me meters squared on the top. Wait, I'm really struggling with units right now. Meters squared, second squared on the top, so it's going to be meters on top. So yeah, so we'll end up with is newtons per meter squared. Okay, so delta P, if you plug all that in, you get 76,125 pascals or newtons per meter squared, depending on how you want to write it. Okay, and then for reporting purposes, give me 3 sig figs. Okay, so KPA. So this is the one you should box in, and this is the one you should work with. Okay, because this one we're going to keep 5 for work. Okay, report 3. Okay. And if you guys were ever wondering, I generally grade to 2. And if you do this rule, you'll always get it right to the 2. Okay, here, number C. Okay, now we want to know what this H is. So now we know delta P from here to here, and we're looking for this, which means, well, if we're looking for this H, we have to use a manometer. Now, there were a lot of errors here. A lot of people forgot to account for this water on this side. I don't know if you guys just looked up an equation for manometers, but we'll go ahead and do it. So I'm going to call this distance right here capital H, and it should be obvious already for some of you if you haven't figured this out yet, that going down from 1 to here through water and then coming back up this side, those two are going to cancel each other. So calling this capital H is great, but it's just going to go away. We'll go ahead and do it. So we'll go P1. Let me get a different color for this. Okay, P1, so over here. Now we're going to go down to here, plus gamma water. We'll just leave it as gamma for now. We'll put a little W on there. H. Okay, so I guess that means a little W as well. Okay, so then that gets us right here. And we need to go from here to here. That's the part that everybody seemed to forget on their homework. Okay, so we'll go plus lowercase h. Okay, so that gets us here. Now we're going to go over to the other side, and now we're going to jump back up. So we're going to go minus gamma hg times lowercase h. Okay, that gets us there. And now we're going to go all the way up. Minus gamma water times capital H equals P2. Okay? And I don't particularly like doing it here we got delta P, and that's P1 minus P2, so I know what that equals, right? But that means basically I'm going to have to, in order to get that, I'm going to have to bring this over to, to this side and bring all this stuff over to the other side, which is why I usually solve for P2 minus P1, or it's one of the reasons. But anyway, we can certainly do it. So P1 minus P2 equals, the gamma water capital H is going to cancel out. So I've got gamma HG H minus gamma water lowercase h. Okay? And so we can, looks like we can solve this algebraically to be, if you rearrange terms, P1 minus P2 on gamma Hg minus gamma water. Okay, or if you, some of you might even prefer gamma water times SHG minus 1. Okay, P2 minus P1. Oh, sorry, P1 minus P2. P1 minus P2. Okay, which is important because you could get a negative number here. That would imply the pressures were in the opposite direction, right? So we'll go ahead and plug in 76, 125 pascals. Okay, and we'll divide that by 9810 newtons per meter cubed, and 13.6 minus 1. Okay, so H equals whatever that comes to, which is 0.61587 meters. Okay, and then to report that, we'll say H equals 61.6 centimeters. Okay, or 0.616 meters. All right, so I hope that was helpful. That's how you do this problem. All right, cool. Signing off.